Hi, this is video 2 in the playlist where we've been looking at the paper 3 calculator paper for the foundation tier. Please do follow the link below in the description, download the paper, have a go at each of the questions. Well, keep stopping the video, have a go at each of the questions and compare your solutions with the solutions that we're going to go through. So we finished in the previous video at question 13. We're going to start here from question number 14, which deals with tins of beans and jars of jam. Okay, all right, so what we're saying is the total weight of 3 tins of beans and 4 jars of jam is 2,080 grams. So I'm just going to write that out just to make it easier for me. I'm going to write that as 3 beans plus 4 jam equals 2,080. Okay, now then it tells us that the total weight of 5 tins of beans is 2,000. So therefore, if the total weight of 5 tins of beans equals 2,000, okay, then to work out 1 tin of beans, so 1 beans, I can just do 2,000 divided by 5. And because this is a calculator paper, you can work that out fairly easily at 400 grams. So that's going to be 1 tin of beans. Now, if we go back to our original equation here, it means I've got 3 beans plus 4 jam equals 2,080. Okay, so I could then put 3 beans plus 4 jam equals 2,080. So I appreciate I'm repeating myself there. But then if I put that 400 into here, that's going to give me 1,200 plus 4 jam equals 2,080. Okay, so if I then take 1,200 away from this side and move it over here, I'm going to take away 1,200 from 2,080, so it's going to give me 4 jam equals 880. And then if I divide through by 4, I get 1 jam equals 220 grams. So actually that answers my question, where I've got 1 tin of beans is 400 grams and 1 jar of jam is 220 grams. Okay, I hope that's all right for you. I have written it down as kind of an algebraic sort of expression or equation, but it's just really to illustrate it. I've written B rather than beans and J rather than jam. Okay, so hopefully you'll be able to follow my reasoning through as you work through that. We are towards the middle of the paper, so it is going to take a little bit of time to work through some of these questions for yourself. Okay, let's move on then to question number 15. And question number 15, we've got 25 boys and 32 girls in a club, and it says 2/5 of the boys and a half of the girls walk to the club, and the club leader picks at random a child from the children who walk to the club. Okay, well, let's not worry about that for the moment. Let's worry about trying to work out how many people actually walk to the club. Okay, so if we look at boys, then 2/5 of 25 boys actually walk to the club. So if you pop that, use your fraction key on your calculator to type in 2/5, and of in maths always means multiply, so it's 2/5 times 25, and that's going to give you 10 boys who walk. Okay, same exercise when we look at the girls. So girls is going to be a half of 32, and that's going to equal 16 girls who walk. So what we're actually saying is the total number of people who walk to the school is going to be 26, or walk to the club is going to be 26. Then it says work out the probability that this child is a boy from the club leader who picks at random a child from the children who walk to the club. So we know there's 26, and we know there's 10 boys out of the 26. So the probability of a boy, so prob of a boy is going to be 10 out of 26, and actually that's the answer to the question. You can leave it as 10 out of 26 if you want to, or if you want to you can reduce it to 5 out of 13. It's good practice to reduce fractions when you see them. Okay, so it's 5 out of 13. probability of a boy being picked at random. Okay, so let's move on then to question number 16. And question 16 is a little bit, I think 16 is quite tricky actually. It says change 72 kilometers per hour into meters per second. All right. With these types of questions, you really have to be quite logical in your approach to them. Try to work down the page if you can. So the first thing is I've got 72 kilometres. So it follows then that would be 72,000 metres per hour because there's 1,000 metres in a kilometre. Okay? Then if I want to work out how many metres per minute, okay, well, there's 60 minutes in an hour. So if I divide 72,000 by 60, that's going to give me 1,200 meters per minute. Okay, so we're not quite there. We've got meters per minute, so the meters fine's okay. We need to then work out meters per second. Okay, well, there's 60 seconds in a minute, so we would have 1,200 divided by 60, and that would be equal to 20 meters per second, and that's the answer to this particular question. So it is a logical step-by-step approach. I appreciate in a video I have to speak fairly quickly, but that would be the way to approach these sorts of questions. Hope that's all right for you. Let's move on then to question number 17, and as I mentioned, these questions are now starting to get a little bit more challenging. We're coming towards the final sort of bits of the paper, really final third of the paper. So in this one we've got a rectangle that's made of card, and then Lily puts 4 of these rectangles together to make a frame. Okay, so we've got to do this sort of thing. We've got to say, well, we need to show that the perimeter is 8x minus 4y. Okay, and it's the perimeter of the inside of the frame, so it's this little bit around here. So let's just have a look at that for a moment. All right, so if we look at each of these sides, what we've got here is we've got 2x, which is the length of this length along here, and 2x, which is the length along here. Okay, and then if you look at this length along here, well, what we need to do is we've got a length of 2x again, but it's actually a measurement of y here and a measurement of y here. So if we look at the inside, we've got 2x minus 2y at both sides. 2x minus 2y. So the way I'll just go over that again. I've got 2x as the overall length, which is this length along here, and then I've got a value of y here, which is this bit here, and a value of y here. So that would become 2x minus 2y. Now when I put all of that together, I can then say, well, the perimeter is going to be 2x, which is this length along here, plus 2x minus 2y, plus 2x, plus 2x minus 2y. And then all we're doing really is just gathering up the like terms to make it 8x minus 4y. So if we have a look at this, I've got 2x, plus 2x, plus 2x, and plus 2x, and that becomes 8x. And then I've got minus 2y and minus 2y, well, that's minus 4y. Okay, so I've shown that the inside perimeter is 8x minus 4y. Okay, then we'll go on to the next little bit. So it says, Magda says, when x and y are whole numbers, p is always a multiple of 4. Is she correct? Well, she is correct, actually, because what we can do is we can say that p, if it equals 8x minus 4y. What I can do is I can prove that that's in the 4 times table. And the way I do that is I just simply factorise for 4. So I can take 4 out and I can make that 2x minus y. And because this 4 exists, then it means that it must be a multiple of 4. Okay, now you might want to prove that just to yourself and make sure that you're okay. So what I'm going to do is I'm just going to prove that, and I'm going to say, well, what about when x equals 2 and y equals 3? Okay, so if that is the case, then I can just plug these numbers directly into here, and I can say, well, 8 times 2 is going to be, if I write 8 times 2, minus 4 times 3, so 8 times 2 is going to be 16, and 4 times 3 is going to be 12. Well, that's going to equal 4, which is actually a multiple of 4. Okay, so I hope that's been all right for you. Sometimes it's good for you to prove it to yourself, but what I'm going to do is that would be the proper way to, well, not the proper way, but that would be the way to prove it if you wanted to prove it algebraically, that you just need to factorise it for 4. Okay, all right, so let's move on then to question number 18. And question number 18, I've got a diagram which I need to remember, in this particular case, a couple of formulas, because we're working out the area of the shaded region. Well, the area of the shaded region is the area of the trapezium. Take away the area of the 2 semicircles, which is actually a full circle. So what I'm going to do is I'm firstly going to work out the area of the trapezium. Now, this is something that I think increasingly you're going to come across, so it's well worthwhile remembering this formula. And the formula is the area is a half a plus b times h. Okay, now A is going to be this length along here, which is 28. B is going to be this length along here, which is 12. And H is going to be 14. So at the moment, I'm just thinking about the whole trapezium. Okay, so I would then have a half. A is 28. Plus B is 12 and H is 14. Now you could plug that into a calculator if you want to, but you're going to have half times 40 times 14, and if you work that out, that's going to be 20 times 14, which is going to give you 200, oops, I've gone off the video there, 280 centimetres squared. So in other words, that's the area of the whole trapezium. Okay, now the other thing that they tell us is that you've got 2 semicircles. Now these semicircles are the same, and the reason we know the same is because the diameter of each of them is going to be 6 centimetres. Okay, well, if the diameter is 6 centimetres, it means that the radius on each of them is 3 centimetres, and that's the bit of information you need, because what we've got here is a full circle with an area made up of pi r squared, a full circle with a radius of 3 centimetres. If I took that half circle out, join it onto that, I would end up with a full circle. Okay, so the area of the circle, and this is the other formula you need to remember, is pi r squared. Now it comes up time and time again on these sorts of papers, so please do remember these areas of circles and perimeter of circle and all that sort of stuff. So that's going to be pi times 3 squared. Well, that's going to be 9 pi. Okay, now just for the sake of the way I generally tend to calculate, if you wanted, you could write all of this out. Okay, I don't quite know what it is because I've just let my calculator do a lot of the heavy lifting. Okay, because all I'm going to do is then the area of the shaded region, so the shaded region is going to be the area of the trapezium, which is 280 minus 9 pi. And if I put that into my calculator, I'm going to get 251.72566661. Okay, now don't lose a mark on this. It does say give your answer correct to 3 significant figures. Well, to 3 significant figures, this is the third number. I'm going to change that to 2 because of this 7 that comes after it. Okay, so that's going to be 252 centimeters squared. Okay, hope that's all right. It does take a little bit of working through on these types of questions, and you need to be using your calculator, but do try to remember the formula for the area of the trapezium and also definitely the area of a circle. Okay, hope that's all right. Let's move on then to question number 19. And again, these are becoming popular. They deal with conversions. So conversions, usually an exchange rate or something like that. So in this particular case, we've got this guy's going on holiday and he changes £550 into lira. So at the moment, we're told that £1 is going to be 3.5601 lira. I don't actually know what the symbol for lira is, I'm afraid. Okay, so if he just had £1 to go on holiday, he would come away with 3.5601 lira in his pocket, which I don't think could go very far on holiday. However, he's got £550 in his pocket, which is going to go a lot further. So in other words, he's multiplied this side by 550. He's going to get £550. Okay, so if I multiply the right-hand side by 550, it means he's actually going to go away with a lot healthier 1,958.055 lira in his pocket. I don't quite know how big that would be, but it's going to be quite a lot of lira, I would have thought. And it says give your answers to the nearest lira. Well, the nearest lira is this one here, so it's 1958 lira. Okay, so then he sees a pair of shoes in Turkey. Okay, I think Turkey is quite well known for its shoes, actually. And the shoes cost 210 lira. Doesn't have a calculator, so he uses 2 to 7 lira to work out an approximate cost of the shoes. Okay, so in other words, what he's saying is that £2 equals 7 lira. Okay, so if we do the same exercise that we did before with the multiplication, he's multiplied that by 30 to get to £60. So if I multiply that by 30, that's going to give me 210 lira. Okay, and it says use this to show that the approximate cost of the shoes is £60. Well, £60 equals 210 lira. Okay, and then finally, question number 19C, it says, is using this a sensible start to as-ifs method? Okay, well, yeah, it is actually, because, and the main reason is because it's very close. It's extremely close, so very close. Okay, because if £2 equals 7 lira, then £1 equals 3.5 lira, which is extremely close to 3.5601. So yeah, it's a very sensible method of doing it, and to be honest with you, it's probably the method that I would use if I was out in Turkey buying shoes. Okay, let's have a look then at question number 19. So in question number 19, we're dealing with something which is appears in quite a lot of maths, actually. It's something called the Fibonacci sequence, okay? And the rule is that the next term in the sequence is the sum of the 2 previous terms. Now, just be very careful about some of this terminology, some of these words that they use. Okay, so I've done this before, actually. You've got these terms. It just means basically this is places, okay? So this is the first place, the second place, the third, the fourth, and fifth, and sixth. Okay, and what it says, the next place in the sequence is the sum of the two previous places. Okay, so let's have a look at that. So the next place is this one here, so 1 plus 1 is 2. The next place then is 3, so 1 plus 2 is 3. The next place is 5, so 2 plus 3 is 5. And the next place is 8, which is 3 plus 5 is 8. So find the 9th one. Okay, well, you could just continue this on. I suggest you do. So the 7th place is going to be 8 plus 5, which is 13. The 8th place is going to be 8 plus 13, which is 21. And the 9th place or term is going to be 34. So actually the 9th term in the sequence, or the 9th place in the sequence, is 34. Okay, and then it says the first 3 terms of a different Fibonacci sequence are that. Okay, but we're doing exactly the same thing. What we're doing is we're saying the first is that, so that's A. Then we've got B, the next is A plus B. Okay, so let's just write that out. We've got the first place is A, second is B, the third is A plus B. So the fourth is going to be then the sum of this plus this. Okay, so that's going to be A plus 2 lots of B. And then the fifth is going to be the same as this plus this, so that's going to be 2 lots of A plus 3 lots of B. And then the 6th place, which is the bit that we're interested in, is going to be the sum of this plus this, so that's going to be 3 lots of A plus 5 lots of B, and that's the answer to this particular question. Okay, so then finally, part C, it says, given that the third term is 7, so the third term, this one here, is going to be 7, okay, and the 6th term, which is this one here, is 29, find the values of A and B. So what we're doing is we're saying when A plus B equals 7, and then the 6th term is going to be 3A plus 5B equals 29. Okay, now with some students, hopefully you'll have done some sort of work on simultaneous equations, and this is what I'm going to do with this. What I'm going to do is I'm going to take the first equation and I'm going to multiply it by 3. Okay, and the reason I'm going to do that is it will give me then 3A plus 3B equals 21, because then it allows me to subtract this equation from this equation. Okay, so 3A, take away 3A is gone, it's disappeared, so I've got 0. So 5B minus 3B is 2B, and 29 minus 21 is 8. Now if I then divide through by 2, I get B equals 4. Okay, so that's actually one of my values, B equals 4. My second one, I can work out, well, I've got A plus B equals 7, so I can say when B equals 4, I've got A plus B equals 7, so A plus 4 equals 7, so therefore A equals 3. Okay, now this will be very difficult to you if you've not done any work with simultaneous equations, but it's probably the easiest way of working this out, and really, as I say, you're in the realms of kind of the higher value type questions now. So if you're not sure about this question, please do add a comment below or have a look on the channel and you'll be able to search through for working with simultaneous equations. Okay, so we're on to now 23 minutes into the video. There's 3 questions left, so I'm going to leave that for the next video. I hope it's been okay for you so far. Please do add a comment below if you're not sure about anything. I'll always come back to you, and I look forward to seeing you inside the next video.